Right, so let's have a look at number 1 here. We have been given the equation of the curve y equals x cubed over 16 minus 4 root x plus 8 over x. And in part A, we've been asked to work out dy by dx. Now, before we can do that, it's a good idea to put everything in index form. So x cubed over 16 is fine. That's already in index form. Oops, let's change that to 16. Minus square root of x is x to the power of a half. And 8 over x is the same as saying 8x to the power of minus 1. So we still only have y. So my first step would have been to put it into index form, and then I can differentiate that. So when I differentiate that, multiply the power down and take 1 away from the power. And in doing so, we get 3x squared over 16 minus a half times by 4 is 2. So we get 2x to the power of minus a half. And positive 8 times by negative 1 is negative 8x to the power of minus 2. So there we have dy by dx. Now in part B, we've been told that the point P, which has coordinates 4, minus 2, lies on the curve. It lies on y. And it says, use your answer to part A to find the equation of the normal. So again, things that I would underline in the question, maybe the word normal, I would underline. Because it's not asking for the tangent, it's asking for the equation of the normal. And we also need to leave our answer in that form, where a, b, and c are integers. Right, so to get an understanding of this, dy by dx gives us the gradient of the tangent if we substitute the x coordinate in. So what I'm going to say is gradient of tangent. It's a good idea to have English description so that you can follow what you're doing in an exam. So the gradient of the tangent will be 3 times by 4 squared over 16 minus 2 times by 4 to the power of minus a half minus 8 times by 4 to the power of minus 2. And if I work that out, that's 3 times by 16 over 16. So 16's cancel out. 4 to the minus a half is the same as saying 2 over square root of 4 minus 8 over 4 squared. And so if we work that out, 3 minus 2 over 2 minus 8 over 16. So 3 minus 1.5 is 3 over 2. That's the gradient of the tangent. Of course, we can just substitute that in there, and that probably would save you time and having to work out complicated things. So let's just check our answer. What do we have? So first I'm going to do 3 times by, and it's a good idea to have your x value inside brackets, especially if it's negative, to avoid getting the signs wrong on the calculator. Minus, what do I have here? 2 times by, in brackets, 4 to the power of minus a half minus 8 times by, in brackets, 4 to the power of minus 2. And we get 3 over 2. Okay, so that's the gradient of the tangent, but we want the equation of the normal. So if we have the gradient of the tangent, therefore gradient of normal will equal minus 2 over 3. So now we found the gradient. We know that the normal passes through the point 4 minus 2. We can label this x1, y1, and then we're going to use the equation of a straight line. So y minus y1 equals mx take away x1. So y minus minus 2 equals minus 2 over 3 x take away 4. Now, the easiest thing to do, instead of multiplying by fractions, is to multiply the denominator of our gradient across. So we get 3y plus 2 equals minus 2x minus 4. And if I expand the brackets and simplify, get 3y plus 6 equals minus 2x plus 8. Collecting everything all on one side, we get 2x plus 3y minus 2 equals 0. Or alternatively, we could have had minus 2x minus 3y plus 2 equals 0, or any multiple of that.